Okay, so here is the solution to this week's Year 12 coordinate geometry homework. As you can see, the question was regarding a parallelogram. So therefore you must remember that on your parallelogram, these two sides are parallel and these two sides are parallel. Okay, so this is obviously going to come in handy later when we're looking at gradients, I would have thought. Okay. The first question leads you in quite nicely. It gives you all four coordinates and then asks you to find the length of PQ. Okay, so to find the length of PQ, first of all what I would do is I would draw a straight line, labelling it P and Q. Okay, and then I'd mark on the coordinates of -5, -2 and -1, 6. And then I would use the Pythagoras Theorem by drawing a right-angled triangle. You can use the formula that you probably learned during AdMaths if you did AdMaths. However, I'd like to do the diagram form. So then we know that PQ squared is equal to 8 squared plus 4 squared. So obviously PQ squared is therefore 64 plus 16. So PQ squared is equal to 80, so PQ is the root of 80. Now if you look back at the question, it does ask you to write it in the form k root 5, where k is an integer. Obviously an integer is a whole number, so if we go back to root 80, you should have been doing some work on the other side of the maths lessons on roots and indices. And you should know that PQ would therefore equal root 16 root 5. 5 times 16 is 80, so we can split that down. Looking for a square number, therefore 16 would be 4 root 5. So PQ is 4 root 5. Part B then asks for the midpoint of PQ. Okay, well, if we go up here, we know the coordinate of P is -5, -2, and Q is -1, 6. So to find the midpoint of PQ, all we need to do effectively is find the mean of the x and the y coordinates. So that basically means adding the x coordinates, -5 add -1 over 2, and then -2 add 6 over 2. Adding them together gives us -6 over 2 and 4 over 2, which means therefore the midpoint of PQ, which I think is denoted as M, is going to be -3, 2. So we now know that M is -3, 2. Part C then asks us to find or show that MS is perpendicular to PQ. Okay, so MS perpendicular to PQ. Well, first of all, we know that M has coordinate -3, 2, and we know that S has coordinate 3, -1. Okay, so the gradient of MS, well, that's y2 minus y1 over x2 minus x1, which would be -1 minus 2 over 3 minus 2, which is -3. Is this? Let's have a look. Let me just double check that. y2 minus y1, x2 minus x1. That should be a 3, shouldn't it? Yeah. So that gives you -3 over 6, which is -1/2. Okay. So you should know by now that if you've got the gradient of MS to be -1/2, then we're hoping that PQ would have a gradient of 2, because we know that multiplying the gradients of two perpendicular lines together will give you an answer of -1. So if we find the gradient of PQ, so P has coordinate -5, -2, Q has coordinate -1, 6. So the gradient of PQ will be y2 minus y1, 6 minus 2, over x2 minus x1, -1 minus 5, which is 8, two negatives making a positive, over -1 plus 5, 4, which gives us a gradient of 2. Now at this point you can't really just leave the question as it is. What you would probably have to do now is then say that the gradient of PQ multiplied by the gradient of MS is equal to 2 times minus a half, which is minus 1, and then we can say therefore perpendicular. It's a fact. Okay, so that's part C. Now part D is asking us to find the area of the parallelogram PQRS. So this is a little bit trickier and we'll probably need a little bit more work. So I think the first thing to do would be to sketch out a better diagram of the situation. So first of all, I'm going to start with an axis, and I'm going to draw in my shape roughly to where I think it should be. So it's looking probably a little bit like that, and up here we've got Q is minus 1, 6. We have P is Q is minus 1, 6. R is 7, 7. S is 3 minus 1. And P is minus 5, 2. And we also know now that M is the midpoint of PQ, which I'm going to put about there. And we know that that's minus 3, 2. And we know that that perpendicular line there to S is also, as it happens, the perpendicular height of the parallelogram PQRS. Now if you remember in question A, we've worked out the length of the base of this parallelogram, which we found to be, what was it, 4 root 5. So now, if I work out this distance here, I'll have the base and the perpendicular height. So if I just take that out and just do a quick Pythagorean triangle on this, calculation on this. So minus 3, 2, 3 minus 1. Drawing my right angled triangle. Like that. So if I am minus 3 to 3 on the x-axis, that would be 6. Minus 1 to 2 on the y-axis would be 3. So therefore, using Pythagoras, we know that ms squared is equal to mp, well, how are we going to write this? Ms squared is equal to 3 squared plus 6 squared. Ms squared is equal to 9 plus 36. So ms squared is equal to 45. So now we know that ms is equal to the square root of 45. Okay, but we also know that we can take a square number out of that. So ms is equal to root 9 root 5, which means ms must be 3 root 5. So we can now put that distance on here as well. Okay, so we know that an area of a parallelogram, so area of a parallelogram is equal to its base times its perpendicular height. That's the little symbol for perpendicular that I'm going to use. Well, the base we now know was 4 root 5. That was the length of PQ. The height we now know is 3 root 5. And what I'd do there, if you're not too sure, is split it all out into your numbers and your surds. Remember commutativity, multiply anything in any order. 4 times 3 times root 5 times root 5 is 12 times root 5, and your rules of surds, root 5 times root 5 is 5, so 12 times 5, so the area of the parallelogram is equal to 60 square units. Thank you very much for watching. There's your answer. We'll be going through the homework in class this week. I hope you've done well because I've not marked them yet. Bye.